All right, we are group 17 in the AA5100 Information Retrieval class. This is our third and final lab. My name is Justin DeCoke.
Yeah, my name is Ranjith Kumar.
Hello, my name is Sachin Patel.
Perfect. All right, and we'll go ahead and jump right in. So to start off our database design, we started with our list of preliminary fields, which was mentioned in the database design from Mere Mortals book. So we considered the data elements required in the assignment as our list of fields. So and then we kind of assigned a subject to each of those fields, and then assigned a more usable field name in the camel case format. So we've got all of these. And then our subjects were salesperson, customer, state, order, items, and items. And then we just had to make a few preliminary assumptions to give us some direction with the data we were creating. So first off, the sample data used for this database will be for a made-up department/electronics store that the salesperson is a title given to an employee, and there can be several different types of employees. And then each employee, regardless of their type, should be in a employee table. And then we also assume that order number detail ID is a unique code assigned to each product sold in the store, and that the order number detail item is the name of that product. So moving on, our database design, or our tables, we ended up with from our list of subjects were employee, job title, department, state detail, customer inventory, customer purchase, and customer order. So these tables were designed with the third normal form in mind, and so each table has its own primary key, and that individual piece of data shouldn't exist anywhere else in the database. So a few tables that we created from the list of fields and kind of the additional fields we thought should go with them to meet that third normal form. So job title and department, like we said before, we assume there's several different types of employees. We also, with our assumption that this is a department/electronics store, we're assuming that there's going to be several different departments, and those departments should be tied to different employees. So each employee will be in the employee table with a unique employee ID, and then they'll also have a job ID, a job title, which and a department ID or department that they're tied to. So then moving on, we did a table for state to reference only the like state abbreviation with a customer here, instead of referencing the entire state. And then an inventory table to store the products in the store. And finally, two distinct tables, customer purchase and customer order. These were done with the design of the customer purchase. Each row is unique by the order ID, customer ID, and item ID, whereas each customer order row is unique by only the customer ID and the order ID. So each row in the customer purchase table is unique by the customer ID, order ID, and item ID, whereas each item in the customer order table is unique by only the customer ID and the order ID. So basically each row in customer purchase represents a single item that a customer purchased, and it's tied to an order ID. So there can be several of the same order ID in this table. Each tied to a different item ID, and that item ID's price and the quantity that they purchased. And actually, the price in the price field in that table is the price of the item multiplied by the quantity purchased. And then the customer order table, each row is a unique customer ID order ID combination. So this also has a total price and items purchased. So it's basically some aggregations of everything that a customer purchased in a transaction, basically. Okay, so this is our database diagram. So this highlights all of the different columns or all the different fields that we created, all the tables and their data types and whether they can be null. And we can also see the direction of all the different primary and foreign keys between all tables, and some key features of the design. This is a three-schema architecture with tables belonging to HR over here, then tables belonging to sales, and then one table belonging to a general schema, which has the information for the US states. Okay, so to get started, we had to do some setup with our SQL script. So we took advantage of the if exists, if not exists logic, and also the object ID attribute in Microsoft SQL Server. Here we just check if the database we're using already exists, and if it does not exist, we create it, and if not, we don't create it. And then same idea here. This sort of, there's several of these, and they drop the tables we've already created. Same thing for all of our constraints, so mostly like keys. And then this is our views and functions. And then over here, this is where we use if not exists, sort of the same way as we do with the database, to create our three different schema. Okay, moving on with DDL. So this is the creation of our tables. So a couple of things to note: all of our primary and foreign keys are explicitly defined using constraints, and each key or each field includes the specification of whether or not that field can be null. Okay, so these are some screenshots or examples of our insert statements in SQL Server Management Studio. So we insert at least 25 records into each table. And then these are just some examples of what our sample data looks like. So we can see here with customers, this is what a customer ID looks like. And then that's referenced here along with order ID and item ID, or sorry, this is an employee ID, which represents the salesperson for that order, and the item ID, price, etc. Here's what the employee table looks like. So you can see it's linked to a job title here, or a job ID here, which is linked to a job title. And then also they're linked to a department ID, which are defined here. And then we can see with the inventory, these are the numbers that are referenced over here as item ID in the customer purchase table. Okay, so here are our functions and stored procedures we created in SQL Server. So first off, we created a function as the assignment required to convert the US dollars to euro. So this is done here, the create function syntax, and we pass a price to it as the float. And then we multiply that price by the current conversion rate from US dollar to euro. And then to get a nice clean number, we use the round function to only get to a decimal places there. And then we also created a very quick procedure to update. We created a null field in the inventory table called euro price. And we created this stored procedure to update all of the, or to pass all of the prices defined in our inventory table and convert them to euros in this euro price column. So we can see how that's called right there. And then this is the results of that. Okay, so next, this is our stored procedure to insert a new salesperson. So for this, we pass first name, last name, level, and department ID. And then basically what we do is this first one is some logic using coalesce, which finds the first non-null value, and the max function to find the current highest employee ID in that table. So the way it's designed, they increment by one. And then it does just that. It increments it by one to get us the first available employee ID. And then the first name and last name just get passed directly to the table. And then this one, since this stored procedure is only for only for inserting a new salesperson into the table, all of our salespeople are defined as SAL1, SAL2, SAL3 for like salesperson 1, salesperson 2, salesperson 3, etc. So that's why we pass a level as an int, so they pass 1, 2, or 3. And then we cast that integer as a varchar and concat it to the end of SAL. And then we just pass the department ID like that. And then this is how we call that stored procedures. This is inserting 3 new salespeople into the database. And then this would be the results of that right here. So we can see how it concat the level that we passed to the end there. Okay, so here is the code for the 4 views that were required with the assignment. So for the customer salesperson, we can see we selected these columns, and then we use this across all of these. This just concats kind of the 2 names, the first name and the last name together to create a more clean view. And we joined the customer order table to both the customer table and the employee table, and then did some group bys to get that the customer salesperson. And then here for the total purchases by customer, same thing. We had the customer table and then the customer purchase and inventory to get the item, and then did some summations on the quantities of items that they've purchased and the amount that those items cost. And then here, this finds the most expensive item by customer. So with this, we used a common table expression, which basically gets a temporary view of some data that we can then select down here. So this finds the row number over partition by customer ID, order by price, descriptions, or descending. So this can kind of be thought of like the enumerate function in Python. So it gets the row number, and it basically iterates over the rows to find the highest row, and then from down here, we out of the CTE common table expression, we only pick the one with the 1 rank. So the highest price basically, and then it's the same exact concept down here to get the most expensive item sold by each salesperson. So here are the results of these views. Okay, so now to get into the Python portion of the project, these are a couple functions we wrote right away to connect and disconnect from the database. So this just makes it easier, kind of lets us, only write 1 line to connect and interact with the database. So this we just pass through this connection string. These are details actually for my local computer, but it'll be the same for the virtual machine, just with the server changed. We also made this select count function, which we will use to just get the count of records in a table, and then we'll use that for some logic in this next function. Okay, so this is a function we wrote to insert our data into Python. So this can be used to insert any data into any of the tables that we have in our database. So it kind of works by passing the table name, the fields that you want as a list of strings like this, kind of exactly what you would write in the select statement, and then the values, which are a list of tuples here. And then finally, this condition fields parameter, which is passed as a list of strings. But as we can see, it works with only one, two. What this does is it's used in this where not exists function, or this where not exists clause in our SQL statement, which our SQL statement is created from taking all of these parameters that were passed and using the f string in Python to kind of put those to concat those together. And oops. So SQL query is created by using the f string in Python and using all of these values that were passed with the function to create a string of a SQL statement. The condition fields parameter is used in the where not exist clause, which basically allows us to pass data that we've already inserted into the database. We can pass it through this function, and the function will still run, but it will not insert data that already exists based on the field that we say the table is unique by. What the output looks like when we successfully insert some data. So we inserted 25 values here, so that would be a list of 25 tuples into the sales.inventory table. And then these were the fields. Then values is the new inventory, that's this list here. And then condition fields is item ID, so we're saying this is unique by item ID. And then there are 25 in there before. From the 25 we put in our DML statements, and they're now 50. So you can see it committed that insert of 25 new records. Okay, and here is the code that we wrote to plot our two diagrams for the project. So this we decided to go with a bar graph or a bar plot for these, and since it's pretty similar data for both, we wrote a function here to do both data, both of them for us. So we pass all of these parameters in, and we can kind of see that in the two that we called here. So this one is for the customers, so we just grouped by customer and got their all their items purchased and their price, and then this is from another function that we wrote, which we may have forgot to put a picture in here, but I'll show it in the demonstration, which basically gets us a data frame from the database. It just uses the pandas read SQL function, and then does group by and passes this through. And then same thing with the states down here. We just group by state instead of customer, and that gets us our visualizations. So we can see that we use the .annotate method here to put the total prices for each of the customers and or states on each of the bars, and then the bar graphs represent the total number of items that were purchased. So these look very similar, obviously, because we are working with just a small subset of sample data, but this in the real world would probably be a much larger number because there's going to be multiple customers purchasing from each state, and as opposed to just by individual customer. Okay, so now we will go ahead and run our SQL script in SQL Server. All right. So we can see all of our messages we printed out, everything is created correctly. And you can see the results of all of this is our inventory table to demonstrate the euro price, and then all of our views. Okay, and then lastly, we will pull up VS Code. We can run all. All right. So we can see this is where we defined all of our database interaction functions. So this is that one I was saying I forgot to put a picture of, and this just creates a select query and then passes that to the PD or the pandas.read SQL function. So here is our new inventory records. So we can see that there are 25 before, now there's 50 since this ran. And then these next few blocks show that no new records are inserted when all of this data is already in the database. So it's going to be the same with all of these. And then lastly, here is our code for plotting our graphs. And then here's where we call both of these functions. That is our Lab 3 presentation for Group 17. Thank you.
Thank you.
Alrighty.